SpaceX demolishes a launch pad ahead of upgrades, but for what rocket? Relativity announces its very own mission to Mars, Rocket Lab's suborbital rocket makes it to orbit, and a spent Chinese upper stage breaks up, endangering Starlink satellites. As always, we've got all that and more coming up this week in Spaceflight. Rocket builder Relativity Space wants to explore the solar system, starting with a mission to Mars in just a few years. And they've already got NASA on board. This week, the company launched its Interplanetary science program, which will consist of deep space missions to gather data about the solar system and made available for scientists around the world. The program's first mission will lift off in 2028, sending a spacecraft to orbit the red planet. The satellite will be equipped with radar to study the planet's geology and subsurface ice, which will not only deliver a wealth of scientific data, but also help to find landing sites for future Mars missions. In addition to this radar instrument, Relativity is partnering with NASA for another scientific payload called ALICE, which is actually a suite of 4 science instruments that will study what's going on inside of the Martian atmosphere. One of the instruments will measure wind and temperature from the surface to an altitude of 60 kilometers, while others will study atmospheric dust, properties of clouds, and measure the balance of energy at the planet's surface, which has a considerable impact on the atmosphere above it. Finally, a wide-field context camera will image all of Mars's atmosphere daily. All in all, ALICE should help scientists to get a better grip on the Martian weather, which NASA hopes will help to reduce risks for future landings, not only for robotic missions, but also for human landings. NASA's Ames Research Center will provide the instruments for ALICE, drawing on experience from NASA's past Mars missions. The agency has agreed to operate the payload for at least one Martian year, and also provide the data processing pipeline needed to get the measurements into the hands of scientists. Meanwhile, Relativity will take care of building and managing the spacecraft and mission operations. Beyond the science payloads, Relativity also wants to install a relay data center on the satellite. As the name suggests, this will bring some computing capabilities to the red planet, but the relay part of the name is important too. It should add another line of communication for existing and future Mars missions. Of course, NASA is already looking for a Mars telecommunications orbiter to fill that exact purpose, and Rocket Lab and Blue Origin keep reminding us that they've got some plans ready to put into action as soon as NASA gives them the go-ahead. The big beautiful bill that funds this mission stipulates that only the companies that submitted a study for the now-canceled Mars sample return mission are eligible to bid. Relativity isn't one of them, but NASA probably wouldn't mind some extra communication capabilities, especially since the current Mars relay network is down one satellite now that the agency has officially ended the MAVEN mission. Anyway, it'll be a while before this mission reaches Mars, and there's still a lot that we don't know. For example, Relativity hasn't officially announced a launch vehicle, though it'll likely be Terran R. The company is working to get the rocket off the ground in the final quarter of this year, and this week they started testing a first-stage test article at their facilities in Long Beach, California. So if all goes well, it should be ready for a Mars mission by late 2028. Well, 2 missions actually, as Terran R will also launch a Mars mission for Impulse Space that same year. But who's paying for all this? Doesn't Relativity have a rocket development program to fund? Well, apparently the company is working on a mission for a, quote, philanthropic customer. Now, they didn't announce who that customer is, but if you'll allow us just a wee bit of speculation, it might be someone very close to Relativity. The company's CEO, Eric Schmidt, founded a nonprofit science institute with his wife, and they previously announced a space telescope called Lazuli. Also set to launch in 2028, this telescope is designed to take over some of the capabilities of the aging Hubble Space Telescope. It'll collaborate with a series of ground-based observatories as part of the Eric and Wendy Schmidt Observatory system, which will make its observations available to scientists around the world as open data. All of this may seem like a bit of a departure from how we've explored space in previous decades, but privately funded science has been around for centuries. NASA has even taken an interest in programs like these. During its recent Ignition event, the agency announced that it wants to leverage partnerships with private and philanthropic research organizations for future science missions, and Relativity says that it wants the Interplanetary Science Program to demonstrate these public-private science science collaborations. Now, it might look like a billionaire sending a spacecraft across the solar system for street cred, but if done well, it could deliver invaluable datasets to scientists down here on Earth and help inform missions to other planets for decades to come. We love science missions here at NSF, so we will certainly keep checking in with this one. And if you want to follow along too, there's a subscribe button nearby. In past episodes of This Week in Spaceflight, we've discussed NASA's attempt to retire the International Space Station to make way for a new low Earth orbit economy with private stations. Well, this week, the United States Government Accountability Office, also known as GAO, issued a report to Congress on the status of those attempts, and it's not going well. NASA is undergoing this transition because the ISS is already old and nearing the end of its life. The agency is mandated by law to keep a continuous presence in low Earth orbit and to not have a gap like has happened in the past. NASA also can't afford an entire station on its own while also carrying out a lunar program, hence the commercialization of the stations. In that case, the companies would bear the cost overruns instead of having the government pay for them. This effort of transitioning from a government-owned station to commercial ones is done under the Commercial LEO Destinations program established in 2019. NASA is carrying out this program in 3 phases, with the first one consisting of selecting companies that could mature station designs and the technology needed to support commercial stations in orbit. The first phase has 6 companies under different types of agreements. 3 of these companies are under a funded Space Act agreement, and they are Axiom Space, Blue Origin, and Starlab Space. 3 other companies are under unfunded Space Act agreements, and they are Sierra Space, SpaceX, and VAST, although only the last one has shown commitment and progress towards launching a space station on their own. Now, the problem with all of this is that it's taken NASA a long time to move from phase 1 of this program into phases 2 and 3. Phase 2 would entail awarding 1 or more contracts to the companies from phase 1 to continue development of their proposed stations. This would include the launch and deployment of the stations, as well as an end-to-end demonstration that it can, in fact, support crew, and that space and ground systems all work according to the design. Phase 3 would then certify these stations and seal the deal, so to speak, for NASA to acquire and purchase space station services with whatever companies are selected under that final phase. As part of its investigation, the GAO identified 4 main risks that could result in a gap of capabilities or the loss of US presence in LEO altogether. The first one is the classic one in spaceflight: schedule delays. NASA currently plans to retire the ISS by the end of 2030, meaning that there are only 4 years left for any company to not only finalize the design of their station, but also manufacture whatever module or modules they need to enable accrued capability, then launch said modules, and operate them for enough time for NASA to certify their station, all that is before ISS is retired. And before all of that, NASA needs to also make a decision on which companies and stations it's finally selecting. As I mentioned before, NASA has still not moved on from phase 1, and they keep changing their strategies. Remember the core module proposal from the Ignition event in March that was suddenly canceled a few weeks ago? The second risk that the GAO has identified is the budget. NASA is approaching a point where it has to pay for the ISS, including all the transportation, operations, and maintenance, while also having to pay and plan for its deorbit and also fund a replacement for it. That's a lot to do with very little money, and this could force NASA to only be able to fund 1 station, which would mean no redundancy if it's late. NASA's budget has also been chaotic in recent years, with proposed budget cuts that had to be saved at the last minute by Congress. According to the report, in 2025, this uncertainty led to NASA canceling a planned ramp-up in workforce needed for the Commercial LEO Destinations program. These 2 risks alone would probably make you think, maybe they just need some more time, it'll be fine. But here's where the third risk comes in: the health and age of the ISS. In recent years, it's become more and more common for us to talk about the cracks in the station in the PRK compartment of the Zvezda module. Those keep appearing, and they keep being sealed, and every few weeks there's another news story about them, just like we discussed last week. But the truth is that NASA thinks that the rest of the station structure may still be good to go for another decade, perhaps even more. So from a structural standpoint, except for the PRK compartment in Zvezda, the station could go on for longer. But that's just the structure. The ISS has many other components to take into account, and they're all showing their age and keep needing more and more maintenance over time. Such is the case that NASA estimates that at least 3 crew members are needed in the station at all times for repair operations and maintenance. And the problem is that if NASA wants to deorbit the ISS in 2030, they need to make decisions on these stations fast. The whole deorbit process actually starts 2 years beforehand, with the first step involving allowing atmospheric drag to naturally lower the station's orbit for a period of a year. Then the US deorbit vehicle, being developed by SpaceX, will launch and dock to the station. 2 years before its launch, NASA needs to give SpaceX the formal go to proceed with its manufacturing and launch, so doing a bit of math here, that would put the earliest decision just less than a year from now in 2027, since this deorbit vehicle would launch 1 year prior to the deorbit of the station. Now, the fourth risk identified by the GAO is the fact that the US alone has only a single crew vehicle, SpaceX's Crew Dragon, and 2 cargo spacecraft for cargo delivery, which are SpaceX's Dragon and Northrop Grumman's Cygnus. Any issues with these vehicles could lead to a gap of capabilities to send crew and cargo to these new stations. NASA is working with Boeing to complete certification of Starliner to carry crew to the station, but there's no guarantee if this will ever be finalized or if it'll even occur on time. Aerospace is also working on its Dream Chaser spacecraft, but a similar logic can be applied to it as well. Based on all of this, the GAO has found that NASA needs to move on from Phase 1 and start with its acquisition of the stations as soon as possible, or at least determine whether the ISS's lifespan needs to be extended or not. The GAO recommended that NASA assess the likelihood of there being a gap in US access and presence in low Earth orbit, including plans to mitigate this likelihood. It also recommended documenting the process of deciding whether the ISS's life will be extended or if it'll be retired as planned in 2030. And this is because, according to the report, whenever the ISS's life had been extended in the past, the decision process had never been documented. One can imagine that not documenting this can make it harder when managers and employees come and go over the years, and then it's suddenly time to decide whether to extend the station's life all over again. It's safe to say that some of these risks and the concerns and recommendations that the GAO showed in this report weren't that hard to see or identify even from the outside. We've been talking about them in some shape or form for a while now. But the fact that this is the Government Accountability Office puts more emphasis on the problem that NASA's facing and gives it even more credibility. Hopefully the agency can get out of this situation quickly and something fruitful can come out of it. Now we'll take a look at some other stories across space, starting with SpaceX, who has demolished the legacy structures at Space Launch Complex 6 in Vandenberg. This has been a long time coming. The U.S. Space Force gave the lease of the site to SpaceX in 2023, following the final Delta IV Heavy launch from Vandenberg just the year prior. From 2024 until the fall of 2025, SpaceX had been undergoing an environmental assessment of the site to launch Falcon 9 and Falcon Heavy rockets. In 2025, the Space Force gave SpaceX right of entry to the site, culminating in the demolition this week. The structures demolished were the mobile service tower, the fixed umbilical tower, and the tail service masts. The big question now is whether SpaceX will proceed as planned with this launch pad and turn it into a Falcon launch site, especially given that the company is winding down Falcon operations. It's true that it's not an immediate stop of operations. Trust me, they still launch these rockets quite often. But the amount of time until that launch count hits 0 for Falcon could be only a handful of years away or less. This launch complex is big enough that SpaceX could consider launching Starship here instead. After all, they're already turning an old Delta IV pad into a Starship launch site out at Space Launch Complex 37 in Florida. Of course, this would also mean that the company would have to go through more environmental reviews and all sorts of paperwork, but whether they go with Falcon or Starship there, those legacy structures are now gone. And it may not be long until we end up finding out which way things go. We often say that night launches can turn night into day, but sometimes day turns into night while rocket engines fire up. This was the case for the BE-7 engine from Blue Origin, which conducted a 41-minute duration burn starting at dusk and ending at night. According to the recorded and public history of spaceflight, this was the longest continuous burn of any chemical rocket engine in history. This would surpass the previous record held by an RS-25 engine that was tested for a burn duration of 2,700 17 seconds, or a little over 33 minutes, twice in 1988. This BE-7 is the main engine that Blue's Blue Moon lander will be using in the future, and it already has to conduct really long burns by default during its mission. Particularly, its apogee raise maneuver to head to the moon is expected to last about 17 minutes. While that's quite a bit shorter than this record of 41 minutes, it's never a bad idea to test the limits of engines when it comes to long burns, just in case. This week, Astrobotic unveiled their first fully integrated Griffin lunar lander ahead of its transport for pre-launch testing to NASA's Jet Propulsion Laboratory. This transport should take place this coming week, marking a major milestone in its readiness for launch. Once at JPL, the spacecraft will undergo qualification and acceptance testing to ensure that it can endure the conditions of launch, space, and the lunar environment. Several payloads have already been integrated with the lander, but its biggest one, Astrolab's Flip rover, won't be integrated until the lander arrives in Florida and is undergoing launch preparations. That launch is currently set to take place later this year on a SpaceX Falcon Heavy rocket, which will send it on its way to the moon. It'll be the first mission of Astrobotic with its new Griffin lander, following the ill-fated mission of the company's previous Peregrine lander, which failed shortly after spacecraft deployment. Hopefully this time around, they'll be even more lucky and ace the landing. Preparations for the next Artemis mission continue in full swing across various NASA centers. Following the announcement of the crew of Artemis III, the primary and backup crew have begun their training for the mission at NASA's Johnson Space Center, starting with familiarizing themselves with Orion systems. While the flight crews start their training, ground control teams have started launch simulations within Firing Room 1 and 2 at the Launch Control Center in Florida, simulating the day of launch operations for the mission. This included a rundown of the terminal count operations and testing the sequence of events in those final critical moments of the countdown. Now, it is true that right now there's no physical rocket with which to test this countdown, but the Exploration Ground Systems teams are working on solving that problem by putting together the SLS rocket for the mission. This week they received the first of the 4 RS-25 engines that will power the core stage for the mission. This SLS core stage has been in the building's High Bay 2 since April, undergoing integration with its engine section. Once that work is complete, these engines will be installed on the rocket and functional tests will be performed to ensure that they're installed correctly. This will then allow engineers to move the core stage from High Bay 2 over to High Bay 3 for stacking on the SLS mobile launcher. It may not be long until we see that work, so stay tuned for more Artemis updates in future episodes. Dawn Aerospace has raised $25 million of Series B funding, which they intend to use to finance some ambitious plans. The New Zealand-Dutch company has been working on a spaceplane called Aurora, and they've already clocked 64 test flights. None of them got anywhere near space, though, as they're only just now expanding the flight envelope to supersonic speeds and altitudes above 24 kilometers. But it might be getting to space soon, as Dawn wants to send the vehicle above the Kármán line twice in one day within 12 months from now. Now, don't get all excited if you were hoping to make regular rides to space yourself. While this space plane will fly above 100 kilometers, it's tiny, only 5 meters long, and its payload capacity is limited to 15 kilograms. But these short space flights might be perfect for testing space hardware or some quick manufacturing in microgravity. Besides the spaceplane business, Dawn has also been working on satellite propulsion. More than 50 satellites currently use Dawn's thrusters in space. Earlier this year, the company announced an in-orbit refueling network called Loop. The system will consist of expendable propellant depots and reusable spacecraft that will transfer the propellant between the depots and the satellites. Dawn's SatDrive satellite propulsion module also includes a docking port that supports refueling. The company plans to demonstrate Loop in 2028. It sounds like a great way to extend the useful life of satellites, so we're excited to see that mission get off the ground. Hubble and Webb have joined forces to study some fossils at the center of our galaxy. No, they're not dusting off old bones or anything. Turns out that a clump of stars was something different than what astronomers originally thought. Near the center of the Milky Way is a cluster of stars called Terzan 5, and astronomers used to think that it was a globular cluster, which is a dense spherical group of stars. Not just a few, but tens of thousands to millions of them, and they typically all have the same age. But not Terzan 5. In 2009, astronomers found 2 different star populations inside of this cluster, and in 2016, we learned that they were entirely different generations, separated by 7 billion years. Now Webb has had a look look at this cluster too, and it saw some things that we hadn't been able to see before. Since Terzen 5 is located in the central region of our galaxy, it's also obscured by dust. But Webb sees infrared light, which passes right through the dust clouds, allowing the team to see many more stars than before. Lo and behold, Webb found 2 more generations of stars inside our blob. The youngest stars formed 2.5 billion years ago, and the oldest 12.5 billion. While astronomers could think of some explanations why a globular cluster could have 2 generations of stars, these are all ruled out with now 4. So it's not a globular cluster. But what else could it be? Well, the team believes that we're looking at the remnants of a massive ancient system that merged into the Milky Way's bulge, the clump of stars at the center. But it didn't fully mix, and somehow Terzen 5 stayed together, surviving to the present day. The astronomers now call it a bulge fossil fragment. So I guess maybe you could say that Webb helped to dust off a fossil at the center of our galaxy. By the way, we just did a deep dive on the James Webb Space Telescope and some of its more recent scientific findings with its systems engineer and project scientist on this month's Astro Live. So if you want to learn more about this incredible observatory, be sure to check it out. NASA is ready to rescue a different one of its space telescopes. The Neil Gehrels Swift Observatory studies gamma-ray bursts from orbit using its 3 telescopes, observing the universe in visible and ultraviolet light, as well as X-rays and gamma rays. It was launched in 2004, but like any satellite, its orbit has been slowly decaying, and the increase in solar activity in recent years has only accelerated that process to the point where Swift will soon return to Earth if no action is taken. But help is underway. Arizona company Catalyst Space Technologies has been working on a spacecraft to reboost the observatory. The spacecraft, called Link, will meet Swift in orbit, grab it, and boost it to a higher altitude. Impressively, Catalyst has designed, built, and tested Link in a very short amount of time, as they were only awarded the contract in September. But now the spacecraft is attached to its rocket, ready for launch. The ride to space will be Northrop Grumman's Pegasus XL rocket, which launches from underneath an airplane. The air launch setup gives it the flexibility to reach the required low inclination orbit by flying out of Kwajalein in the Marshall Islands. The launch is currently set for June 27th. It'll most likely be the final Pegasus XL rocket, as it was the last one in storage and they're not currently making any new ones. This might also mean the end for the Lockheed L-1011 TriStar carrier aircraft called Stargazer, which is the last one of its type still flying. But hopefully, the airplane and its rocket can use their last hurrah to give a space telescope in need a new lease on life. Kind of poetic, isn't it? This is your weekly space traffic report provided by Next Spaceflight. Let's start off this report by issuing a correction, and kind of a weird one. Last week we mentioned that Rocket Lab had launched its suborbital HASTE rocket from Wallops, but as it turns out, the US Space Force cataloged 2 objects in orbit from that launch, so technically it was not suborbital, but wait a minute, isn't that just a normal Electron rocket launch? It's a bit strange because if you go to Rocket Lab's own website, they cited this mission as being under their HASTE program, despite it reaching orbit. The 2 objects in orbit were also identified as being rocket bodies, implying that these could be the rocket's second stage and the kick stage above it. The orbit reached was also extremely low, barely reaching 200 kilometers in altitude, which means whatever was launched would have naturally come back down to Earth within a day or 2 due to atmospheric drag. These HASTE missions are often performed under the utmost secrecy, so it's not like we have a lot of information to theorize what happened here. What we do know is that they tend to take advantage of Electron's ability to reach high speeds in order to test hypersonic vehicles or materials. But was the payload separable, or did it stay attached to the rocket's upper stage? Was it deployed during ascent, or did it go into orbit along with the rocket? If this was intended to test any sort of re-entry, these 2 questions are rather important. The orbital track is also suspiciously lined up with the Utah Test and Training Range if you project the orbit to a full revolution around the Earth. That site is well known for having been used for the re-entry of space capsules and other vehicles in the past. And even before reaching that location, there's also the vastness of the Pacific Ocean to do whatever kind of re-entry test that Rocket Lab's customers may have wanted to do. In any case, this whole mystery certainly made this mission's name much more understandable, as Rocket Lab definitely threw us a curveball with it. Up in space, we also had a space incident event with the second stage of the Juche 2E rocket that launched last week. Following payload deployment, the rocket's upper stage suffered a breakup in orbit, leaving dozens to hundreds of pieces of debris in orbit. The good news is that it didn't happen in a really high orbit. The orbit is low enough that most of these pieces will likely experience orbital decay in the next few months due to atmospheric drag. That said, it's still a problem for the few hundred Starlink mobile satellites orbiting at around 360 to 380 kilometers in altitude, and that will be in the path of that debris as their orbits decay over time. There's also the concern that this could happen in future missions where said upper stage breaks up in a much higher orbit and endangers thousands more other satellites as well as other orbital debris. Now, finally, let's go over the launches of the week. Interestingly, we only had a single Starlink launch this week, and it was from California. This is because SpaceX's Falcon 9 was busy with customer payloads such as AST Space Mobile Bluebird satellites. The launch of these satellites occurred on Wednesday, June 17th, which also featured another 3 orbital launches from other places around the world. Quite a busy day, huh? These Bluebird satellites are part of a satellite constellation dedicated to delivering direct-to-cell connectivity to users on the ground using massive deployable antennas that act like cell towers in space. Now, if the name Bluebird sounds familiar to you, it may be because one of these satellites was flying on Blue Origin's 3rd New Glenn launch. That one was AST Space Mobile's 7th Bluebird satellite and the second of the newer and larger Bluebird Block 2 satellites. In that launch, the satellite was delivered to a lower than planned orbit, and AST decided to deorbit it. This time around, all Bluebird satellites were delivered to where they needed to go. We also had 4 launches from China this week. One of them carried a batch of Jilin-1 Earth observation satellites, another carried a classified experimental satellite for the Chinese military, and another one carried a batch of Guowang internet satellites. This last launch is notable because it was carried out with the Changzheng 12, which hadn't been launched since January. In the time since, the rocket has been upgraded with a new fairing manufactured out of carbon fiber instead of metal, reducing the overall mass. Engineers have also changed the rocket's fuel from regular kerosene to a new synthetic kerosene that provides a higher density and efficiency in the engine's performance. The remaining liftoff from China launched a batch of Senti Space 1 navigation satellites aboard a Kuaizhou 11 rocket, but it is rumored that perhaps one or more of these satellites might have failed to separate from the rocket. The problem is that there's just no way to verify it if that is the case or not. We also had some rumble in the jungle with the 3rd launch of Amazon LEO satellites on an Ariane 6. This was the 3rd launch of Ariane 6 in its 4 solid rocket booster configuration, and the first using improved P160C boosters, which hold more propellant and provide more thrust to the rocket, boosting its payload performance. Additionally, the 34th SpaceX Cargo Dragon mission returned from the ISS this week with a splashdown off the coast of California. Going into next week, it'll be a week dominated by Falcon 9 launches with a couple of Starlink missions on the schedule and the demo flight of SpaceX's Starfall capsules. It's unclear how that mission will be carried out, but we will definitely cover it in next week's episode. Rocket Lab is also planning a launch of its Electron rocket next week from New Zealand, heading into sun-synchronous orbit. China may also surprise us with some launches from Wenchang and Zhochuan as well. As we always say, the best way to stay up to date on launch dates is to go to nextspaceflight.com or download the Next Spaceflight app on your phone. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.